Hi everybody, my name is Patrick Collins. I'm a smart contract security researcher, co-founder of Cyfrin, where we do smart contract security in the Web3 ecosystem. This is Sergey, obviously, he needs no introduction, and we're here to talk about Web3 security, what's going on. So, Sergey, how you doing?
I'm doing great.
All right, excellent. So my first question to you is, how does Chainlink approach security in Web3?
Sure, so I think the whole thesis of the decentralized infrastructure industry and the blockchain industry is decentralization, right? So you have multiple independent nodes generating consensus, computing the same result, and then you're adding various different levels of cryptography, sometimes new cryptographic primitives like some of the ones created in the Chainlink community and various other techniques, basically. But at the core of it is really decentralization. And so that's really what I think Oracle networks have done, is they've proven that you can apply decentralization and consensus to things outside of a blockchain. So a blockchain generates decentralized computing and consensus around three things: private key signatures, token ledgers, and relatively limited state machines that often can really only interact with the data within a blockchain or the information within a blockchain, and they can't interact with other chains or existing systems. And so blockchains kind of proved this new field of decentralized computing by doing consensus on these three things. But then the security from that can now be, the security from that decentralized computing approach should be able to be applied to other computations. And that's what Oracle networks do. So the whole goal of the Chainlink network is to apply decentralized computing to all the other computations outside of a blockchain. And then it's a very natural relationship with chains, because chains have this very high standard for deterministic, verifiable truth and cryptographically guaranteed inputs, which Oracle networks are the best generators of. So the goal with all the work on decentralized computing is security. So really the security model is decentralized computing.
Yeah, 100%. And you mentioned actually private keys just really briefly. I know we were talking more about compute. The private keys thing is something that's always really frustrating for someone like myself, right? So when we do security reviews, when we do audits, we see code bases that say, don't look at this line of code. Yes, we know it's centralized, but like, don't worry about it. And as a result, I know we've talked a little bit beforehand, we've been seeing all these bridge hacks happen where you have somebody who just controls all the private keys, they get hacked, whoops-a-daisy, we lose $200 million. What does Chainlink do to fix that, to remediate that?
Yeah, sure. So not surprisingly, decentralization.
Surprise, surprise.
So the CCIP protocol, which seeks to be the TCP/IP of blockchain, cross-chain communication, basically is now possible both for data and value, and the combination of data with value. But to answer your question about how the security works, basically it's the use of three separate Oracle networks to execute a CCIP movement or data transfer every time. And this is very different than the traditional approaches that you have in bridges, because most of the time it's one or two servers, or it's a number of servers that are controlled, as you said, by one key. But in the CCIP system, there are literally three Oracle networks that are all computing the guarantees that are written into the system and coming to consensus. And not only are there three Oracle networks, there are actually two separate roles. So there are two separate categories of networks even. One category of network, the transactional category, which is where you have the committing decentralized Oracle network and the executing decentralized Oracle network. Those basically process the actual transaction and are involved in the signing of the consensus to prove that that transaction meets the security and accuracy requirements that it needs to meet. Those networks right now are made up of about 16 nodes, but we expect them to increase variously between different bridges. Then there is the risk management network, and the risk management network has a completely different role. The risk management network doesn't actually do the transaction. It monitors and approves or denies transactions based on their various risk characteristics. So do they meet certain policies? Do they meet certain expectations about being a real or a fake transaction? And so not only do you have multiple networks, but you have multiple roles. And then also these two groups of networks are written into different implementations in different languages. So there's also a certain amount of client diversity where you have two separate implementations. So you have a very large decentralization at the node level. You have a new level of decentralization where there are actually two different roles that Oracle networks take on. And this is the first time that we have multiple Oracle networks powering a single decentralized microservice like a CCIP bridge. And then you also have client diversity because you have two separate implementations for those two separate roles. And so at all three of these levels of diversity and decentralization, you have a whole different level from what you see elsewhere. And this is why it took over 3 years to get CCIP out, because it's actually a very complex problem, but it's a problem that was very well informed by our work and the community's work on generating data transfer. Because fundamentally, cross-chain communications is basically data transfer, whether it's about value or whether it's about information. And Chainlink and the Chainlink network model, the decentralized Oracle network model that Chainlink basically invented and originated, has already securely processed over 8.5 trillion in data transfer, right? So that is the experience that all of this additional work is built on. And that's why this level of decentralization exists, because there's this understanding of how to create the decentralization that creates real security.
So we're talking about these three dons that are executing. We have almost like redundant decentralization. One of the most frustrating things for us as security researchers, we see a lot of these protocols that are like, oh, we're decentralized. Look, here's our docs on how to run a node, and then you do a deep dive into the protocol, you do a deep dive into the service, and you go, oh my goodness, all these nodes are run on the same cloud VM. It's run by the same guy. It's run by the same the same family or what have you, and it's incredibly frustrating when they get hacked. When we have solutions like this that actually work. So what is some of these stoppers? Like why? And then to me, I think I look back at myself. I'm like, oh, I'm not yelling loud enough. I need to educate people more as a security researcher. But why do you think a lot of the groups aren't taking this seriously? That they're playing this decentralization theater, if you will.
Well, because I think it's difficult and complex to create real decentralization in a repeatable, manageable, verifiable way. So what most people do that are trying to make an Oracle network or an Oracle network-based service, whether it's for data or whether it's for automation or whether it's for cross-chain bridges, is often they make a single server and then they make a website. And they say, I have a blockchain data service, or I have a blockchain automation service, or I have a blockchain bridging service. And because people don't fully understand the security of that, they're like, oh, okay, you say you do this, great. We've now reached at a point where there's enough of these data-related failures and bridging-related failures and automation-related failures that people now ask, okay, they at least ask, how are you secure, how are you decentralized? Then they kind of play this game where they say, oh, it's okay, we have two servers. We're decentralized. There isn't one server, there's two servers. And then they kind of, they basically call distributed computing decentralized computing. And then two servers isn't enough, so they turn it into 20 servers, right? And this is the story of things like multi-chain, where it's basically, great, I have 20 servers, but they're all controlled by me. That's the distributed computing. That's not decentralized computing. But they call it decentralized computing because they've gotten questions about what is it, how is it decentralized? And the answer they want to give is, oh, I give multiple things. I provide multiple servers, so it's decentralized. Then that story doesn't work, right? Because really how it works with security, as you know, is that the more value in a system, the more sensitive to security people become. If you have $1 in a system, you're not that sensitive because the dollar isn't really at risk, because very few people are going to go and expend the effort worth more than the dollar to get the dollar. But if there's $1 million, okay, that's a risk. There's 100 million, that's a bigger risk. There's $1 billion, okay, now you're on someone's target list who actually knows what they're doing. You go past $1 billion, now you're probably on some bigger target lists, and so on, right? So everyone whoever gets to a point of securing any real value, they naturally evolve into asking about security. And because the security model of our industry is decentralization, they naturally progress to asking about decentralization. So then this story of like, oh, my distributed computing where I control all the, unless they lie. So if they just lie, then there's, you know, then you need to do all kinds of verification. But if you, you know, if they get tired of telling people this stuff and calling distributed computing decentralized computing, then they actually do make a network, right? So they make one network, and that network is run by different nodes. And that's where most, pretty much everybody stops, right? They stop at that point, and they basically say, I have this network, and I'm going to pump everything through it, everything. I'm just going to send everything through this one network that I made to make a data service or a compute service or a bridging service. And the problem with that is that that really doesn't scale. If you could pump everything through this one network, then blockchains would also scale. But blockchains don't scale, right? Because blockchains don't scale, we have L2s, we have L3s, and then we have progressively even deeper levels of L4, L5, L whatever. So the difference between people that make this service and evolve it into a single network and the Chainlink network is the Chainlink network is a framework for generating multiple separate networks. And it's generated over 1,000 networks on production and basically generated real security by repeatedly generating more networks. So the difference is that the people who have one network, they're making a system to make one network work a little bit better. And the Chainlink network and the Chainlink framework is a way to generate now thousands, soon tens of thousands, then hundreds of thousands, then millions of networks. And so this is the very big difference. And this is actually also why we can build CCIP in the way we're building it, is because CCIP is like the Chainlink framework has now gotten so good at generating multiple networks that we can even combine multiple networks into a single service, which is something nobody does. So the reality is that it's just very hard to create real decentralized security. And it's even harder to make a system that allows the creation of multiple decentralized systems the way that Chainlink has. But that's the Chainlink network's goal. It's not, there is no Chainlink chain, there is no one Chainlink Oracle network through which everything passes. There is just a way to generate thousands and thousands of separate networks that can scale their security and their ability to process data or compute or cross-chain with the security requirements of the systems that they're affecting.
Yeah, actually, so if you came to my SmartCon talk from this year, actually, the first half of 2023, this year, the top type of attack vulnerability was price oracle manipulation, around $200 million. Now, a whole bunch of attacks have happened since then, but price oracle manipulation was one of the top ones. We see stolen private keys, which goes back to centralization. We still see some classic reentrancy issues, and there's a list of things that most protocols should be thinking about before they go to review, before they even start thinking about building. And unfortunately today, like a lot of them are not doing that, which is really, really frustrating. So for anybody who is into smart contract development, there's two resources that you should definitely check out. One is the Rect test, and it's just a list of 12 questions just to make sure, hey, if I launch this, am I gonna get wrecked? One of them is, have I done an external security review with security professionals? Do I have my external services, external contracts, like Oracle's, documented, and do I understand exactly what they do and how they work? Have I run the most modern tooling like Slither, like a Fuzzer? And it's this wonderful list by the Trail of Bits team that everyone should definitely reach out to. There's also a tool called this nascent simple security checklist. Because I could literally rant about, here are all these things you need to think about. There's so many things you need to think about, but that list, and then the other big thing I would say is somebody needs to have ownership over security of the protocol. Right at the beginning of building your protocol, you need to say, okay, you are in charge of security. You need to be the one who, just one person, you need to be the one who makes sure we've checked all of our boxes. One of the things that's really tough about security is it's known as a negative deliverable, right? Like, it's not going to increase your revenue. You spending a lot of time on it, it might not be seen on the other side. But if you don't spend time on it and you do get hacked, you will see a huge negative outcome, right? So one of the things that is great is we are seeing a lot of protocols understanding that, and they kind of do a very quick cost analysis. They go, okay, I could spend $1 million in resources on security or get hacked for $200 million. What's a better use of my resources here? Luckily, a lot of them are getting much more serious about it, and serious about decentrality, especially when it comes to Oracle use as well. A big thing that we see that's unfortunate is a lot of protocols to this day, they go, don't worry about our Oracle use, that's not in scope for the security review, right? And the researchers, the auditors, they go, okay, cool, you're not gonna pay me for that. Okay, well, I'm not gonna spend time on that, so it's out of scope. And unfortunately, that's the exact vector that is gonna get attacked. When you are working with external systems, your smart contracts it's immutable code, and every single external contract that your smart contract touches, you need to have documented, you need to know exactly what it does, and you cannot say, oh, it's out of scope, because our contract is our contract. Everything your contract touches needs to be in scope. Even stuff as simple as like ERC20s. There are a ton of malicious ERC20s, malicious tokens that will destroy your protocol. And unfortunately, we've seen that happen a lot. So that's my rant on what we need to be doing and what we need to be thinking about here. You were talking a little bit before, you were saying, hey, like sometimes people run a node, sometimes people run 2 nodes, maybe on the same VM. Before we started recording here, you were talking about the 5 levels of security or the 5 levels of decentrality. It sounded like we were almost kind of going into that. Could you explain more, like what is this 5 levels of security that you're talking about?
Yeah, sure. So we consider the 5 levels of cross-chain security. Level 1 is when there's a single server run by a single private key holder. That's not decentralized in any way. And that's just a centralized service where that key holder and that one server are both their own attack vectors. So if anyone gets into that server or anyone gets access to that private key, you have real problems. Then there's the second level where people basically have the bright idea to make 2 servers that they still control with one private key. So now there's one private key controlling multiple servers. Sometimes people call this decentralized. It's not decentralized, it's just 2 servers, it's distributed. And then they jack that up to 20 servers, however many servers they want. This is the story of things like multi-chain and mixin and so on, where you have one key holder controlling a system that can break the whole system, basically. So one key holder controls 20 nodes, great, that's not really decentralized. You get that one key to stop doing things, or you get access to it, and that's it. The whole system can stop, or you can lose value. The third level is when people reach any amount of decentralization. It's when you have multiple independent nodes with multiple independent keys coming to consensus about, cross-chain events. That is the level that 1 or 2 things have reached at this point, but their whole strategy seems to be, let's pump everything into one collection of nodes, into one network of nodes, and that strategy creates 2 big problems. The first one is it's not scalable. It doesn't create a place where it can process all of the transactions and cross-chain events that are going to need to happen across all chains, because the scalability of these consensus methods really just isn't there. If it was there, then we would have scalable blockchains. And the second problem is that everyone gets everyone else's risk. So if you have a small bridge and you don't want to take the huge risk of everyone else, then you're now pulled in together into this big honeypot with everyone's risk. And that's the place that people are going to attack. So the third one creates some amount of decentralization, but it's not scalable, and it's not a good idea. The fourth one is really where you reach some level of scalable decentralization, and it's the level that Chainlink has been at for well over 3 years. It's the ability to make multiple separate networks. So this means that each service has its own network, its own distinct separate collection of nodes, that their only goal is to make sure that that specific bridge, that specific service works properly. The benefit of this is that you can scale up the amount of nodes or the security guarantees of that specific network as the value in that specific bridge increases, and you can maintain scalability because that network is only responsible for that bridge. And so this is the capability that Chainlink has had as an Oracle network to create multiple separate networks for years. This is actually what Chainlink was made and started to do. And because the Chainlink network is so good at creating separate Oracle networks, you arrive at a place where you can now make bridges using multiple networks in any one bridge. And this is what CCIP is at the 5th level of cross-chain security. It's the ability to make multiple individual bridges that are made up of multiple networks. And in CCIP, we have the committing network, the executing network, and the risk management network. So each CCIP bridge isn't even a single network with multiple nodes. It's multiple networks with multiple nodes. And then at the 5th level of security, I would say that CCIP is at the very height of that, because you actually have networks with different roles, and the different networks are actually differently written. They're written in different implementations in different languages as separate systems. And so you kind of have the 5th level with multiple networks, but we've gone even further than that with CCIP by creating a diversity of clients and creating separate roles for the networks to perform, which is something you can only do when you have multiple networks. And so this is really, I think, the level of security you need to transfer real amounts of value and important information that then can trigger the value. And that's the other key property of CCIP. It's the ability to combine the value with messages so that when the value reaches its destination, it can actually trigger events, which is also giving more control to the system, but you can give that control because the security of the system is at this immense level of decentralization through these multiple networks coordinating with each other to verify and approve transactions that not only can move value, but they can move the value and they can tell it what to do and make sure that happens when the value reaches the destination where it's arriving.
Hearing all this gets me incredibly excited. Obviously, I've been a builder in this space a long, long time. Having this functionality to be interoperable with all these different chains unlocks just countless possibilities. What are some of the different protocols, the different ideas, the different designs are you excited for with Chainlink CCIP?
Yeah, I mean, there's a huge amount of things that people can do. One of the most basic things that I've seen start getting a decent amount of adoption is wallets and smart contracts being able to use other contracts on other chains without integrating onto that chain. So the experience before CCIP for using bridges was take value out of your wallet, put it into the bridge, use the bridge, get the value out of the bridge into the wallet that you had to make on the other chain, go to that wallet. From that wallet, use the application you want to use, receive whatever it's doing for you, put it back in your wallet, send that back through the bridge, take it out of the bridge, and put it back on the chain from which you initially sent the value, right? Like this is an example of buying an asset on another chain and sending it back to your original wallet. So all of those 5 to 10 steps are now condensed into one step with CCIP. And what this effectively means is you're now able to go into a wallet, and you're able to just say to the wallet, I would like to use this application on that chain to do something very specific. So you can say basically, I would like to go to blockchain X, smart contract Y, and execute function Z without you ever even having to have a wallet or an address on that chain. And what this means is that whatever place you have your value, whatever chain you have your main smart contracts in, can now use all of the other contracts and all of their functions in other places, which basically means that you no longer need to go to those places to natively integrate and natively have a wallet and natively have an address and natively secure your relationship with these other places, because that relationship is both simplified and secured through the decentralization of CCIP. And this capability is useful for creating unified liquidity. It's useful for creating unified voting schemes across different chains. It's useful for creating wallets that have user experiences where you can use 20 different DeFi smart contracts from 20 different chains without ever having to leave the wallet as a user, because the wallet can now coordinate all that activity across the chains through CCIP. So those are some initial examples, but it's actually a very, very powerful feature that lets people stay where they are and use all the different capabilities of chains from the place where they already have created their security for the private key that controls the value they have. And so instead of having to create private key security in 20 different places to use 20 different chains, you create it in one place, you secure the value in the chain that you really started in or want to keep it in, and then from that place you use the rest of the blockchains and smart contracts out there. Very similarly to how in TCP/IP on the internet, you can have your own database technology, and then you can interact with other systems and services through TCP/IP, and you don't need to know or even care about what technology they use, but you can gain the value of interacting with them through this messaging and communications layer that basically creates the internet. And so that's the fundamental goal of CCIP, is to create this internet of contracts that works in this efficient way.
Outside of security, I would say one of the biggest issues in Web3 right now is user experience, and having to change chains, having to jump into whatever wallet you're using in MetaMask, flipping between whatever network to bridge is a huge barrier to entry to people who are not well versed in using these kind of complicated wallets. So what we're talking about here actually, and especially with account abstraction becoming more and more popular, you could have a smart wallet, like a smart contract wallet, where you go into this and you will never have to worry about, well, this is kind of a longer tail in the future, you would essentially never have to worry about exactly what you're saying, what chain you're on, what you're working with. All that is abstracted underneath so that regular everyday users don't need to be DeFi Web3 wizards to interact with Web3. And to me, this is incredibly exciting because now we can actually start to have real conversations about onboarding people who who haven't been in this industry for years and know all the little nuances and quirks.
Yeah. So I think it's a big step forward. The security and the ability to bridge at a very basic level can create a single liquidity layer that allows all the value in all the chains to use all the applications, regardless of what chain you're on. So that's a huge advantage for how the world works. And then the usability is another really big advantage, and that actually feeds the liquidity layer. Because it's so easy to now use contracts on other chains, I could even see people going into some kind of Web3 wallet that is from a Web2 company or from a bank or from some application that they already use, and from that application use a DeFi protocol or multiple DeFi protocols on multiple different chains. And because you've reduced this friction, you get more value into the system. You get more value into the blockchain industry, and because you make it simple for that value to use various DeFi applications and others, you're able to properly kind of grow, basically. So you can launch on chain A, but you get access to all the liquidity and value from all the chains in the world that are connected to CCIP, similarly to how when you get on the internet, you're connected to TCP/IP, and so you have access to all the people and systems on the internet, even if they do not use the same technology as you. Yeah. And so this is a very big usability improvement, because with each additional connection to CCIP, because of these features, it's an additional application, and it's an additional source of liquidity that all the other applications and all the other sources of liquidity now gain access to as well. And so there's this massive network effect that is aided by this additional much greater usability. And so these things work together very well.
All I can think about in the back of my head is, if we got a client who was maybe like a teacher's pension fund for $1 billion, right? That teacher's pensions fund, all they're asking for is they're saying, hey, here's $1 billion. Can you park this in a spot that is absolutely not going to get hacked? Because the worst thing that can happen is we lose this $1 billion. We lose the teachers' futures here, right? And one of the things that's very scary for me in Web3 is I'm terrified that a lot of these not so savvy TradFi people are going to put their money into some liquidity pools that are malicious, and boom, teachers' pensions funds are gone, right? To me, something like what we're talking about here, they don't have to worry about switching chains. They don't have to worry about the usability issues that's going to cause that $1 billion hack. They can come in, be a lot dumber, if you will, and still be safe. Is that something that you're hoping will be enabled with something like CCIP? We'll be able to bring on some more of these TradFi, or excuse me, these Web2 technologies, these Web2 financial instruments?
Yeah, so the capital markets banking industry is this very multi-layered, multi-participant world. Mm-hmm. And the pension funds that you're describing would work with the asset managers and the banks to basically give them certain products. And so then the asset managers and the banks would do a lot of diligence on those products. And then the security and reliability of those products would depend on their use of various infrastructure. and they would not ignore the oracles, right? So they're not under the same time pressure, and they already have a lot of value, and their main goal is to maintain and do what they call wealth preservation, basically. And wealth preservation means managing these various risks. So they already, I know, do look at all the security of all the connected systems that could affect value, and that's a reason that they work with us, and that's why we're working with Swift and a number of large CSDs and FMIs and various banks. It's because the security that has been created in our system through decentralization meets their very high standard. And these people do have high standards for security because they have been securing trillions of dollars for decades, right? They need to have that standard for security. So I would say that the standard for security of the asset managers and banks should mute this problem to a certain degree. They will definitely need infrastructure, and they value infrastructure that provides real security, like Chainlink and CCIP, and the proof of reserves of a Chainlink network, and so on. And so that's why we're working very more and more closely with banks, asset managers, FMIs, CSDs. They will do a lot of diligence on this, and then they will be, I think, pretty conservative. There may be individual TradFi players like prop traders or hedge funds that are not conservative pension funds. And they may use things directly without banks or asset managers, and then they will have the burden of understanding the security and the decentralization of those things. But they will also be more conservative, I think, than DeFi users, and they will only go towards gold standard protocols, because the chance of loss and the risk of going to zero on their assets is an unacceptable risk. And so I think that there will be, it will not be winner take all. It'll be winner take most in many of the cases of these protocols that appeal to the hedge funds and some of these folks. So, and then it'll be winner take most in different geographies, in different asset categories, in winner take most in specific chains, sometimes driven by the banks of those specific geographies or asset classes in those geographies. So it'll be a lot of winners, actually. But I think that as you increase the amount of value, as we mentioned before, the security sensitivity of users and the people enabling the transactions as intermediaries of some kind, like banks or asset managers, they are increasingly sensitive to security.
One of the things I always say is they're never going to come here so long as they keep seeing, $200 million hack here.
Yeah, that's not going to.
Never, right? And this is a big reason why I got into security, because I said if we want to move from 40 billion TVL to 500 trillion TVL or whatever you want to do, right now, exactly as you just said, there's no way they're going to do that right now. Absolutely not.
Not at those numbers. And the other problem is if the same security dynamics that allow hacks for 200 million because one person has one key and one server controlling the 200 million, if that continues and there's an increase of the value in the system, then you can add a zero to that.
Yep.
Because right now we're in a relatively down market, and so it's only 200 million. But when the market goes bonkers, as it sometimes does in our industry, things start getting more zeros next to them, and those additional zeros mean that you go higher on people's target lists, because now there's another zero there. There's a much greater increase in the amount of value at risk, and B, when the loss happens, the loss is newsworthy, right? So the loss is something that it isn't on the CoinDesk website, it's on the Wall Street Journal. Wall Street Journal website.
So we're talking about, so number one, almost like we as a culture need to level up our security game.
Yeah, absolutely.
And we as a culture, especially when it comes to all of these centralization vectors, we're saying, oh yeah, like Oracle out of scope, like it's okay, is basically unacceptable at this point, because it's going to further pushing away all this capital that we need to grow and succeed.
Yeah, I don't think it's a great idea. And once again, even if you do something like that, once you actually have real value in the system, you'll end up having to do it.
Yeah.
Because you'll become security sensitive at that point.
Yep.
So that's just a pattern we see recurringly again and again. If somebody might not be security sensitive because they just launched, they don't have value in their system. As the value increases, they start to realize the kind of seriousness of the situation.
Yep.
And then they become security sensitive, even if they weren't to begin with.
Right.
So you're invariably, the people that don't do this, they end up in these hacks.
Yeah.
And so, and every time a hack happens, it kind of shocks the rest of the world into reality.
Yep.
But that's the reality, is that as the value in your system increases, your need to care about and generate real security massively increases.
But so we need to start driving that home now for the smaller, the 1 million, the 2 million TVL, because those are the ones that are going to grow. And you know, we will never progress if we continue to like be skimp on this issue. We'll never progress.
Our industry has to be a secure, reliable way to store, manage, and transmit value for the entire global financial system as a superior way to do it. That's the standard that needs to be getting met. And you know, that's what we're working on, that's what you're working on. And I think that's what many of the people in our industry work on and take seriously, and we all should.
100% agreed.
Patrick, it's been a real pleasure chatting with you. Thank you.
Sergey, as always, absolutely a pleasure.